30 billion tons of CO2 emissions globally. And the view is that over the next 50 years, that's going to double.
Our problem is ourselves. It's our appetites. We want the world to be a small place in which everyone knows everyone else, and we get to visit and we get to travel and we get to do the things that everyone wants to do. And if we're going to do that, we have to invent the technology that makes it possible without cooking the world.
I guess the way I like to think about it, CO2 is carbon dioxide. It's what you and I breathe out.
The difficulty is not putting CO2 into the atmosphere at all. It's not like it's poison. It's got to be there. It's putting it all into the atmosphere within a short period of time. That's what the problem is.
We can't afford to wait and actually see what happens. We need to take proactive, preventative measures to reduce emissions. Our views on ZEP's future objectives and goals. And we will start by doing that in BP.
Now, to understand the energy problem and the solution to the energy problem, what you have to do is understand where the demand for energy comes from and where the supply comes from. And the three big sources of demand are transportation, electricity, turning the lights on in your house, and everything else. Now, the supplies for energy come primarily from fossil fuels. Coal goes into electricity, oil goes into transport, gas supplies all of these things. There's some nuclear power, smaller than the fossil players, but still significant, and there's some hydro. And there's a tiny but growing dot over here of renewable. To solve the climate and energy problem, what we need to do is to preserve the energy sources that meet the demand, which is in fact growing, especially as the developing world develops and gains an increasingly Western lifestyle, while not releasing greenhouse gases to the atmosphere.
BP, especially through its alternative energy segment, was developed back in 2005, has recognized that the future will be different and that our energy balance will change. And so BP is currently focused on solar, wind, biofuels, and then this transition that we're talking about, which is carbon management, or CCS.
So a gas-fired power plant emits about 2 million tons per year. A coal-fired power plant emits between 5 and 10 million tons a year. The Nsala project is a demonstration of CO2 storage. It stores about 1 million tons per year.
When we thought about it more deeply, we started to see the potential opening up for broader application of that technology as a way to reduce emissions, particularly from the big emitters of CO2, which is power plants.
Catastrophic climate change can only be avoided if industrial nations adopt a new technology known as carbon capture. The technique involves trapping carbon dioxide emissions from power plants and burying them deep underground.
If we make the logical assumption that we will continue to use coal, for example, as a power source in the US, in China, and many other parts of the world, then the only technology that's really available today to try to do something about the carbon problem is CCS.
Because we just can't install enough renewable energy or even build enough nuclear in the short time frame we have to make the emission reductions. And we will be reliant on fossil fuels for the next 50 or so years.
What CCS does is it allows you to keep the energy flowing, but keep the CO2 that used to rise into the atmosphere, and you put it into the ground instead.
A lot of people think that the reservoirs are underground lakes, but in fact they're not. They're in sandstone, we call it clastic, or limestone, and it's like a rock sponge. This is the kind of reservoir rock that we drill into to produce natural gas from. About 15% of this volume could actually hold and trap CO2.
And effectively it's capturing that CO2 during the combustion of the fossil fuel and then taking that via pipeline to an old oil and gas field and storing that back in the rock where the oil and gas once was.
People struggle to understand how deep these formations are. 2 kilometers is how deep you would normally store CO2 under thousands of meters of solid rock. So site selection and management in terms of CO2 storage is the key thing to get right. And oil and gas companies have been doing site selection and management for oil and gas operations for 100 years now. So we have a 100-year track record of being able to identify good sites to develop for oil and gas. And these are very similar to the sites that you'd require for CO2 storage.
BP has a deep core competence in understanding the subsurface, which means that it lends itself well to tackling the issues and challenges around CO2 storage. Understanding what are the right characteristics that will allow CO2 to be stored safely in deep saline formations. And that's work we currently have ongoing and will be an important contribution that BP can make to CCS.
One of the things we're proud of is the development of satellite technology. What's interesting about that is that it's non-invasive, so the satellite can detect tiny, tiny ground movements from outer space. The data from the satellite is publicly available, so it's not just us that are saying the CO2 is securely stored. Members of the public, academics, whoever can go and access the same data that we're using and come to their own conclusion as to whether the CO2 has been securely stored.
Of course, carbon capture and storage is not a kind of visionary, nice tool, just like wind or solar energy. It's part of a necessary mix to bring emissions down quite drastically. And it's a transition technology to a fully renewable energy future, as we would like to see it by the mid of the century.
My vision is it will just become a routine part of our business. It's just another stage in the refining process of progressively cleaning up the industry of power generation and other industries as well.
For us to realize that vision, we need to really work on developing new technologies to reduce the cost of CO2 capture and compression, and to prove you can store the CO2 long-term and safely, so it doesn't go back into the atmosphere.
We think Abu Dhabi and the Middle East is a real sweet spot for this type of technology, because you have this convergence of growing power demand with a need to decarbonise the country's footprint, with the coincidence of prolific oil fields that will benefit from the use of CO2 for enhanced oil recovery. So right now what we're working towards is designing and building the world's first industrial scale hydrogen power project coupled with carbon capture and storage. What we're relying on, I think, is for governments around the world to put in place an appropriate fiscal or monetary incentive so that commercial entities do undertake the building of more of these plants, because to make the difference that's needed, we don't need 10 or 20, we need hundreds if not 1,000 of these plants to be built by 2030.
CCS deployed on a widespread scale could probably solve a quarter or a fifth of the climate change problem.
We're not going to solve this problem entirely by CCS, but is CCS an important fraction of the solution? And I think the evidence there is yes.